Look at platforms like Amazon or YouTube. You are seeing thousands of individual elements, buttons, images, and text fields, all rendering at once. If you were building this manually, you would have to write the explicit code for every single one of those pieces. Traditionally, this was done through imperative programming. Developers had to write out manual, step-by-step instructions for the browser to create each piece of the interface. First, create a container, then add a heading, then attach a specifics file, and finally place it on the page. The flaw in this approach is that it doesn't scale. If a developer builds a standard navigation bar with 30 lines of code, they have to copy and paste those 30 lines across every single file in the project. If the design needs to change later, that developer has to find and update every one of those 50 files individually. This method of building a user interface is like carving a sculpture from a single block of marble. It creates a rigid, interconnected unit. Once the layout is carved, you cannot easily take a piece of it and reuse it in a different project. As the internet grew, these monolithic blocks became too difficult to maintain. To build faster and handle more complexity, modern web engineering moved towards snapping together small, modular, standardized interlocking bricks. This shift led to declarative programming. In a library like React, developers no longer micromanage the browser with step-by-step commands. Instead, they describe what the interface should look like, and the library manages the execution details in the background. This chart compares the two workflows. On the left is the long list of execution steps required by the old method. On the right is a single compact block that simply tells the browser to display a navbar. That block is a custom component. It is a modular piece of code that acts as a blueprint for a specific part of the user interface. This allows developers to focus on the overall architecture of the site. They can design how the system should function without having to manually instruct the browser on every minor update to the page. We can see how this works by looking at a single, isolated element, like a video thumbnail on a homepage. A custom component is a JavaScript function that returns user interface elements. It acts as a factory for a specific piece of the UI. Inside this function, we use a syntax called JSX to package everything the element needs. The HTML structure, the CSS styling rules, and the raw logic are all defined in this one place. This setup fuses these three layers into a self-contained package. Everything required for the component to function and look correct is bundled together. Once the component is defined, you can render it as many times as you want. You can take that single function and stamp it out over and over to create a row of video tiles. But if you render the same component 4 times, you get 4 identical clones. Without unique information, every tile will show the same thumbnail and the same title. This component provides an efficient mold for the layout, but it remains static until we can feed it unique data for every instance. To solve the cloning problem, we use props, which is short for properties. These allow us to pass unique data directly into each instance of a component. Props function like custom attributes. We can pipe a specific image URL, a title, and a view count into the tile to transform the empty wireframe into a finished piece of content. This allows the site to scale. One single component blueprint can receive different props millions of times to populate every unique video on the platform. This creates a separation between design and data. The component function manages how the information is displayed, while the props provide the actual information. Adding these props transforms these static layout molds into the data-driven components that make modern, personalized web pages possible. When we look at the entire application, we see how these individual pieces fit together to form a larger architecture. This structure is called a component tree. It's a hierarchy where small child components, like a video tile, are nested inside a parent component, like a video list, which sits next to a sidebar. The entire system rolls up into one master app component. When the site loads, this hierarchy snaps together to form the layout the user interacts with. Because the system is built from these blueprints, updates are efficient. If you want to change the font size on every video title, you only change it in the video tile component once, and that change appears across the entire site instantly. By breaking interfaces into these isolated pieces, developers can manage a level of complexity that would be impossible to maintain using manual imperative methods. Building for the web has evolved from writing individual pages to composing scalable systems.